Hi guys, this is Shweta. So today I'll show you how to rig a Rubik cube. So I'm doing this for 8 cubes. The 27 cubes is an assignment for you guys to try it. Okay, so let's get into it. So how I constructed the cube is I have a few outer controls over here which will rotate, and I have a few geometry over here for all the cubes, and I have a few joints for the respective cube. These joints are bound to the geometry, and I have a control too for the respective joints. And now I've got shape here too. So this shape will determine the position of the joint. So if we rotate this outer control, this particular control will be affected by all the outer controls. So I have a shape here, knobs shape, to determine the position of the joint. Okay, so I have a root sphere here as well. So this is the midpoint of all the cubes. So you can just select all the cubes, create a cluster. This is the midpoint. I have just snapped this sphere to that cluster. Okay, so that's all I have in the construction. And with the shapes, you're free to use whatever you want. You can also use locators for instead of spheres. So yeah, I'll just explain the script. I'm just importing the MEL commands into Python. So as CMDS. So I don't need to type maya.cmds every time I try to call commands from MEL. So I have declared this function named value fun. So I would recommend that you have a basic idea of at least loops in programming language, because I won't be explaining each and every loop. So yeah, so I have here value fun. So I have declared this as global because I want these values to be implemented in other functions as well, which are inside it. So that's why I've declared this as global. So what I have did here is I took the shape and I'm querying its translate value. So get shape 1 will store these values -232, and I'm rounding off. So why to round off? Because sometimes the value is 2.001 and the outliner just shows 2. So to avoid this kind of problems, I can just round it off, round off the numbers, the translate values. Then after rounding it off, I am converting that values into int decimal values. So it's more manageable as well. That's why. So coming over here is I have value cube. So what this value cube is, I have just traced the translate values of shapes. So let's see, for box 1 shape it's -232 and the value cube 1 is -232. So these are all the translate values of shapes. So here I have put all the get shape values of all the cubes and put it into single array. For same I did for val cube. I have put it into single array named value. Print get shape just for checking that if it works or not. And what I am doing here is mm, I am I am taking the index of val cube and seeing that where did that get shape go. As I told you, the shapes can change position if we rotate this. So if this shape 5 is in shape 1 position, then the index value should be swapped for both these shapes. So our in any programming language, the array always starts with 0. So let me show that to you. Okay, so if I have initial values as a, b, c, d, and its translate value I have traced it, so it's a, b, c, d. So if this value change, if this is b, a, c, d, it will just compare this a values to the b and see if it's swapped. So this is 0, 1, 2 and 3. So over here 0 is swapped with 1, so output will be 1, 0, 2, 3. So this basically will return the numbers from starting from 0. That's what index is. For shapes, these are just the index value. I am taking all of these index values and sketching it into shapes. This is just a list and print to see if it works right. Control list. I've taken all the control names over here. This is possible with loop as well. I suggest you to try it with loops. I've taken the names of joints as well and put it into a joint list array. So here I have declared another function named execute. So now here I have declared the value fun as global function. Over here I will call the values which are in the global function. If it wasn't global, then the values won't be called inside execute. And now here there is a loop running, so I have an empty array named privileged. So what this is doing is check the shape, meaning index position. So here we swapped with 0 and 1. So here what this loop will do is, now we have box 1, box 2, box 3, box 4. So b1, b2, b3 and b4. So what this loop will do is, this will swap according to the index value which we got. So it's 1, 0, 2, 3. So this will swap like b2, b1, b3 and b4. So that's what happening over here. So now for the outer controls, so here is just a group of what all joints are corresponding to the outer controls. So for group pcon we have 4, 1, 5, 2. That's group p. So we have group p over here. So 5, 2, 6, 3. So now, as I said, array always starts from 0. So I have naming convention starting from 1. over here. So there is 5 2 6 3. So to match with the array index, we have differentiate by 1. So here it is 4 1 5 2. So that's what I did over here. So for secon it's group C and its adjacent joins. For group A, group D, up down. Yeah, that's all the same thing which I did for group con. Over here I am just sorting the joins. Is the same thing which I did with controls. I'm just swapping the joins in this loop. So these are all also the same as this. Okay, so whatever I'm selecting, it's stored in selected, and I have a few groups. These are just the names of the outer control. So we are tracing the rotate value of group up over here. So it's different for the side controls, as side controls will rotate on. It will rotate on. It will rotate on rotate X. So it will be different for side controls. So for up control is rotate Y. That's why I have traced the rotate Y value. So I have two blocks over here. First we'll check if the selected cube is equal to group up. So if you have selected group up, it will just check if you selected group up or not. Then it will just parent the controls, the controls inside the corresponding group. So let's check it out. Now I am working with up, so I'll just select the up control. Sorry about that. And okay. So as you can see, the corresponding controls have all grouped under their respective outer control. So that's what this does now. Now for the next we have one more loop, and inside that we have two blocks of if statements. Now this will query the long name of the joint. So we have as this output, we have group 1, group 0 and joint. For example, we have this. So this is the long name, and long name will return this 3 as one array. So that's what this statement is doing right here. Now for nodes, so this is just one element, so we can't loop this, or we can't use this as individual elements, so we need to split it. So exactly we are splitting it right now. Group 0 and joint. So this is 0, this is 1, and this is 2. So we have 3 elements now in this array. So this node will just split it. Now if C x for x in nodes shapes is true, none, and CMDS node type transform. So we have joint and we have null up. So this null up will be returned in C if it already exists before. So now if we create any geometry, if we are creating sphere, so we turn on the shapes. Now there's a shape node and transform node. This is the case for all the objects you create in the scene. There's always a transform node and shape node. If you delete the transform node, only the group is left. So that's what we are checking over here. if shape, there is no shape inside it and no type is transformed, then it's empty group. So it will just query that and put it into C. So now over here the output of C should be group 1, group 0. The join shouldn't be included. This is the output of C. So after that we are checking if C is not empty and C is empty. So if C, there is a group above the joint and there is some element in C, then this will execute. If there is no element, then this will execute. So C of 0, that means the first element. The group 1, the topmost group will be queried over here. And null up hash. Hash, what hash does is, if you have 5 elements, 5 group in the scene, then it will just create a 6 group, added suffix 6. So it will just go on incrementing, duplicate group of same names being created. So yeah, now we are querying the pivot of root sphere. So P, Q is for query, W is for world space. So we are querying the pivot of root sphere in world space, and then we are setting the group's pivot to root sphere. So 0 is the group we have just created. In this case here we have created null up 4. So yeah, so we are setting the pivot, then we are keyframing it at y. We are keyframing the group at y here, so it has been keyframed. So the second block is similar to first block, is just take the joint and groups the joint if there is no group above it. Okay, so the second block of up, it will check that it's rotated at 90 or not. So if we rotate this at 90, so let's say we rotate this at minus 90. So we rotated this at minus 90 and let's execute the script and see. So what happened just here? We have first the empty array defined over here. This will contain the groups of this loop, will return the group names to empty array. So this will return the group 1 means 0th position of every control in group upcon to UG. So yeah, count is 8. 8 is just basically the number of cubes I have here. So if you are going to use 27 cubes, then just specify the value over here. Then for current time I have set that at 10. As you can see here, the current time is 10 and it's keyed. So the next step is just keying. So first the controls are just under the outer control. So first the group will be unparented and there will be a keyframe set at 10. The shapes will be unparented. First the group will unparent itself, then the shape will unparent itself. And as you can see here, if we unparent the shape, there is a value of rotate y. So we need to freeze transform that. So that's basically what we are doing here. We are freeze transforming the shape. So yeah, next we are just unparenting the control. So if you unparent the control, this also has rotate y value. So we need to freeze transform that too. So we are freeze transforming it. So you can see rotate and translate, because there is decimal values of translate over here too. That's why we need to freeze transform it. So yeah, Now the next statement will just, it's parenting back the shape. So the shape will just parent itself back to control. Now the next is the group will parent back its control, and in the end the outer control will be freeze transform at rotate. All rotate values will be freeze transformed. So yeah, now we'll just execute this, and if we go back, okay, now you get this. Now if you this +10 current time is entirely up to you. If you want to change it, then it's totally fine, you can change it. So that's it. I'll show you how this works now. Let's select this. We have set that keyframe at 20, right? So go to 20. Suppose I'm selecting this. Okay, so yeah, I'll do the same thing for this too. Okay, so it's rotating at Y. Then this control. Okay, so I'll rotate this. Alright, so if we go back, so yeah, that's what this is. You can, as I said in the starting of the video, you can do this for 27 cubes too. So I'll just show the 27 cube. So here I have 27 cubes. It just works the same way, like that. Okay, so I'll just rotate this. Okay, so it was like this. Now I hope you enjoyed this video. If you have any doubts, queries, you can leave the comments below. And thank you so much for watching this video.